All right, here we go. We have an example that tells us we have the perimeter of rhombus ABCD is 28 centimeters. One diagonal of the rhombus is 12 centimeters. Then we have triangle BCE is within the rhombus and its isosceles with base BE. So let's just start marking the picture with what we know. All four sides of the rhombus have to be congruent, but then we have an isosceles triangle in there with base BE, so that means side BC is congruent to side EC in that triangle. And since the perimeter of the rhombus was 28, each side length has to be 7. So each side is 7. I'll put the kind of the tick mark up there for that one. So each side is 7, 7, and 7. They told us one diagonal is 12 centimeters. So there seems to be like there's going to be a lot of clutter in this diagram over here. So I'm going to draw I'm just going to duplicate rhombus ABCD. I'm just going to take out, kind of ignore the isosceles triangle for the moment. So just redrawing rhombus ABCD. Each side is 7. And it told us that one diagonal was 12 centimeters. Well, remember that in a rhombus, the diagonals are perpendicular to each other, and they both bisect each other. So they are both perpendicular bisectors of one another. So if one diagonal's length was 12 centimeters, then it was divided up into, it was cut in half. So part of it is 6, and the other part is 6. And then I'm going to mark our right angles there. And then since the diagonals are perpendicular to each other, and diagonal AC was also cut in half. Okay, so since the diagonals are perpendicular bisectors of one another, then there's 4 smaller right triangles that each share a vertex at the location where the diagonals intersect each other. So that should help us solve for the length of the second diagonal. So let's call that half of it right now x. So step 1, we can go with x squared plus 6 squared is equal to 7 squared. So it means x is going to equal the square, or x squared is going to be equal to 49 minus 36, which is 13. So that means that x is equal to root 13 units. So that means that the diagonal AC is going to be 2 root 13 units long. So now we should be able to get the area of the entire rhombus. The area of the entire rhombus, since a rhombus is a kite, we can use the 1/2 diagonal 1 times diagonal 2. So diagonal 1 was 12, diagonal 2 is 2 root 13. So half of 12 is 6, 6 by 2 is 12. So the area of the rhombus should be equal to 12 root 13 centimeters squared. All right, so kind of maybe call that step 2 of our work right now. So now I'm going to bring that work over here. So now I have a rhombus, and another way that we can get the area of a rhombus is by the base times height formula. So if I go with like step 3 here, the area of the rhombus can also be expressed as the base multiplied by the height. And the base would be 7, but the height would be perpendicular to that base. So notice that the height that I marked there would be the same as the height of the isosceles triangle, right? So those heights would be congruent to each other. Okay, so well, since I know the area of the rhombus, and I know that the rhombus has a base of 7, I'm going to be able to figure out the height of the rhombus, which is the same as the height of the isosceles triangle. So 12 root 13 centimeters squared is the area of the rhombus. The base of the rhombus is 7, and the height is what we don't know. So when we divide by 7, we know now that the height is 12 root 13 over 7 centimeters long. Okay, well, now I'm kind of seeing two different possible ways that we can figure out the area of the shaded part. The shaded part is a trapezoid. Because in a rhombus, opposite sides are parallel. So AE would be parallel to DC. So it's a trapezoid. Or I could do the area of the entire rhombus, which I already have, minus the area of the isosceles triangle. And in order to do that, I need to figure out the length from E to B. I need the base of that triangle, right? Well, knowing the base of that triangle would also allow me to know the second base of the trapezoid. So kind of either of those ideas is in play, but I need to figure out how far it is from E to B. So to do that, I'm going to call E to B, I'm going to call that 2y units long, 2y. And then that height in the isosceles triangle goes to the midpoint of the side, so it bisects the side if it's a height drawn in an isosceles triangle. So this has to be y, and this has to be y. Well, since I know the height and I know the hypotenuse is 7, I can use the Pythagorean theorem to solve for y. So step 4 there, I'm going to do y squared plus the height squared, which was right above. So y squared plus the height squared should be equal to the hypotenuse squared, which is the hypotenuse is 7. So y squared plus 12 root 13 over 7, that's the entire height being squared, is equal to 7 squared. All right, well, that's going to tell me y squared plus, when you square this, you're going to end up getting 1,872 over 49 is equal to 49. So then when I solve for y, I'm going to subtract 1,872 over 49 from both sides. Okay, so I'm going to end up having y squared is equal to 49 minus 1,872 over 49 will leave me with 529 over 49. You take the square root of that and you end up getting y is equal to 23 over 7. Well, since EB is 2y, that means EB is equal to 46 out of 7. Well, if I want to just think of the shaded part as a trapezoid, I'm going to redraw that trapezoid over here. So step 5. If I redraw that trapezoid over here, I have trapezoid AECD, where AD and EC are congruent to each other. DC we already know is 7. But AE must be 7 minus 2y, so 7 minus 46 out of 7. So the distance from A to E must be 7 minus 46 sevenths. Okay, and we already know the height, because we calculated that up here. The height is 12 root 13 over 7. So the area of the shaded part should just be the area of this trapezoid, which would be base 1. So let's do base 1 is 7 plus base 2, which is 7 minus 46 sevenths, divided by 2, multiplied by the height of 12 root 13 over 7. Okay. The question says we can round to the nearest tenth. You could keep this exact if you wanted to, so the exact answer would be the area is equal to 312 root 13 over 49. But it did say round to the nearest tenth, so we'll say that the area is approximately 23. I think it was like 22.95-ish. So that would round up to 23 centimeters squared in this case. All right, hopefully that was helpful.